Most people who fall in love with H-shaped barndominiums never hear the truth until it's too late. They see the renderings, the sprawling wings, the dramatic rooflines, the private bedroom suites tucked away from the main living space, and they imagine their family thriving in all that separation and style. It looks like the perfect layout for multi-generational living, for hosting, for giving teenagers their own zone while grandparents enjoy quiet mornings in theirs. But here's what structural engineers are finally saying out loud in 2026. After years of watching these builds age, H-shaped floor plans create failures that don't show up on day one. They emerge slowly, invisibly, in places homeowners never thought to inspect until the damage costs tens of thousands to reverse. The problem isn't the dream. The dream is beautiful. The problem is how that dream gets executed in steel, concrete, and fasteners under real-world forces that most families never consider when they're sitting at the kitchen table sketching out their ideal home. Let's be honest about what draws people to the H-shape in the first place. You want privacy without feeling like you're living in a hallway. You want your master suite on one wing, maybe your in-laws or older kids on the opposite wing, and a wide open great room connecting them in the center. You want that courtyard effect, the covered outdoor space tucked between the wings where your grandkids can play protected from wind and sun. You want the layout to look intentional, architectural, like something that says you put thought into how your family actually lives. And on paper, it works. The flow makes sense. The separation makes sense. But here's the truth no builder warns you about. Every time you add a wing, every time you create an L or a T or an H, you're not just adding square footage. You're multiplying the structural complexity in ways that silently punish you for decades if the engineering isn't perfect. And in most cases, it isn't. Imagine this. You're 2 years into living in your H-shaped barndominium. Everything still feels new. The paint is fresh. The floors are beautiful. The HVAC hums along. Then one morning you notice a hairline crack above the doorway where the center section meets the left wing. You tell yourself it's just settling. How's a settle, right? 6 months later, that crack is wider. Now there's another one near the ceiling in the hallway. You call someone out, and they start talking about differential movement, thermal expansion, inadequate connection details at the joints. Words you never heard during the build. Words that come with 5-figure repair estimates. This is the story structural engineers are seeing again and again, and it all comes back to one thing. H-shaped buildings have multiple wings that want to move independently. And if those connections aren't designed and built to handle that movement, the whole structure starts tearing itself apart from the inside. You might be thinking, wait, my builder said steel frames don't crack. And you're right, steel doesn't crack the way wood does. But the connections between those wings, the places where one roof line meets another, where foundation slabs join, where walls intersect at angles that aren't 90 degrees, those are the places where the forces concentrate, where water infiltrates, where expansion joints should be, but often aren't. Most families never ask about these details because they don't know to ask, and most builders don't bring them up because explaining them is uncomfortable and expensive. So the plan gets approved, the build moves fast, and the hidden weaknesses get buried under drywall and metal roofing until years later when the evidence becomes unavoidable. The engineers who finally started speaking openly about this in late 2025 weren't trying to kill anyone's dream. They were responding to a pattern they could no longer ignore. One structural engineer out of Tennessee shared that in the last 18 months alone, he'd been called to assess 7 different H-shaped barndominiums, all between 3 and 6 years old, all showing the same constellation of problems. Cracks radiating from interior corners where wings meet. Doors that won't close properly because the frames have shifted. Windows that bind in summer and gap in winter. Roof valleys collecting water that should be shedding. These aren't cosmetic issues. They're symptoms of a building that's moving in ways it wasn't designed to move, and every year that passes, the movement compounds. What starts as a nuisance becomes a structural liability, and what you thought was a forever home starts feeling like a countdown to a major renovation you never budgeted for. Here's what's really happening beneath the surface. When you build an H-shape, you're essentially creating 3 separate structures trying to act as one. The center bar of the H and the 2 wings each have their own load paths, their own thermal expansion rates, their own settling patterns depending on soil conditions under each section. If your foundation isn't a monolithic slab with properly designed control joints, the those 3 sections will settle at different rates. If your steel frame doesn't have engineered moment connections at every junction, those wings will flex independently when wind loads hit. If your roof system doesn't account for the different spans and slopes where the wings tie into the center, you'll get ponding, leaks, and eventually rot in the decking no matter how good your metal panels are. Most barndominium kits and pre-engineered building companies don't detail these connections the way a custom structural engineer would, because custom engineering costs money and slows down the sale. So they give you a frame that works in theory on flat ground, with no wind and perfect construction. But you're not building in theory. You're building on real soil that shifts with moisture. You're building in real climates that swing 40 degrees between morning and afternoon. You're building with real crews who might not understand why that connection needs 4 bolts instead of 2. Now imagine you're the family who chose the H shape specifically because you needed separation. Maybe your aging parents live with you, and they need their own wing for dignity and independence. Maybe you have adult children boomeranging home, and you can't handle everyone in each other's space all day. The layout solved a real problem for your family, and walking away from it because of some engineering talk feels impossible. But here's the part that hurts. The families who regret their H-shaped builds aren't upset because the layout doesn't work for living. They love the layout. They're upset because the building itself is betraying them. One family in North Carolina told their story in a forum last fall. They built a gorgeous 4-bedroom H-shape on 10 acres, spent close to $400,000, moved in, and for the first year, everything was perfect. Then the cracks started. Then the HVAC couldn't keep the wings comfortable without running constantly. Then they realized the courtyard between the wings, which was supposed to be this protected outdoor oasis, turned into a wind tunnel in winter and a heat trap in summer because the orientation and the shape funneled air in ways they never anticipated. They didn't regret wanting the layout. They regretted that no one told them how to build it correctly, or that building it correctly would have added $30,000 in engineering and materials they didn't know to budget. This is the hidden cost no one talks about. H-shaped barndominiums can absolutely work, but only if they're engineered as H-shaped buildings from the ground up, not as rectangular buildings with wings tacked on. That means deliberate expansion joints, properly tied rebar in the slab, moment-resisting frame connections, flashing details at every roof intersection, separate HVAC zones with returns planned for the geometry, and usually a general contractor or builder who has done this before and knows where the mistakes hide. If you're working with a barn kit company that specializes in simple rectangles, or a local crew that's never framed anything more complex than a ranch house, you're gambling with long-term failure no matter how confident they sound during the bid. And the failure isn't always dramatic. That's what makes it so insidious. You don't wake up one morning to a collapsed roof or a foundation split in half. You wake up to small things that nag at you. A door that used to swing freely now drags on the threshold. A window that whistles when the wind picks up. A section of soffit that's pulling away from the fascia just slightly, barely noticeable unless you're looking for it. You mention it to your spouse, and they say it's probably nothing. Maybe the wood shifted, maybe it just needs a shim. But 6 months later, there are 3 more spots like that, and now you're wondering if you're being paranoid or if something is genuinely wrong. That doubt, that slow creep of anxiety every time you walk past another crack, is what engineers say families describe most often. It's not catastrophic failure. It's the erosion of confidence in the single largest investment you've ever made. It's lying in bed at night wondering if you should have gone with the simpler rectangular layout, if you should have spent more on engineering up front, if this is going to get worse and how much worse, and whether you'll even be able to sell it someday if you need to. Let's dig into the specific engineering vulnerabilities that make H-shaped builds so prone to these problems, because understanding the why helps you protect yourself if you're set on this layout. First, there's the foundation issue. Most barndominium builders pour a slab-on-grade foundation, which is cost-effective and fast. But when your building has multiple wings extending in different directions, that slab experiences uneven loads and uneven moisture exposure. The wing facing south gets hot, expands, contracts. The wing facing north stays cooler, contracts less. If the slab isn't thick enough, if it doesn't have sufficient rebar tied correctly at the junctions, those different expansion rates create shear stress right where the wings meet the center. Over years, that stress microfractures the concrete, and those microfractures become pathways for moisture, which leads to spalling, undermining, and eventually structural sag. A proper H-shaped foundation should either have control joints designed exactly where those wings meet, allowing intentional movement in controlled locations, or it should be thickened and reinforced at those junctions to resist the movement altogether. Most kit builds do neither. They pour a uniform slab and hope for the best. Second, there's the roof. H-shaped buildings create complex roof valleys, and valleys are where water wants to go. If those valleys aren't flashed with standing seam details or commercial-grade underlayment, if the pitch isn't steep enough to shed water quickly, you will get leaks. Not might, will. One builder in Missouri said he refuses to do H-shapes anymore unless the client agrees to a minimum 612 pitch and ice and water shield in every valley, because he got tired of callback visits for leaks that showed up 2 or 3 years post-construction when the fasteners started backing out due to thermal cycling. The problem is that a lot of families fall in love with the low-slope modern farmhouse aesthetic, that clean roofline that doesn't look too barn-like, and they spec a 312 or 412 pitch because it looks better. Then they learn the hard way that looks don't shed water in a valley, and water doesn't care about aesthetics. Third, there's the frame connections. Steel frame barndominiums rely on bolted connections, and every place where a wing meets the main body is a place where forces change direction. If those bolts aren't sized for the actual loads, if the gusset plates aren't thick enough, if the columns aren't braced for lateral movement, the frame will flex. Flex leads to fastener fatigue. Fastener fatigue leads to loosening. Loosening leads to movement. Movement leads to everything we've been talking about: cracks, gaps, doors that don't fit, a building that feels like it's slowly coming apart. Engineers now recommend that every H-shaped build get a stamped set of plans with explicit connection details for those junctions, not generic details pulled from a kit manual, but stamped plans from a licensed structural engineer at cost and time. And a lot of families trying to keep the build under budget skip that step, reassured by a builder who says he's done plenty of these and knows what he's doing. But here's the uncomfortable truth that builders won't always admit. Experience with simple rectangular barndominiums doesn't translate to complex shapes. The forces are different. The tolerances are tighter. The mistakes are less forgiving. A builder who has framed 50 successful rectangular barns might frame his first H-shape using the same methods and assumptions, and that building might look flawless at ribbon cutting. It's only 3 winters later, after freeze-thaw cycles have worked on the foundation and wind events have tested the connections, and the HVAC has run thousands of hours trying to balance temperatures across wings with different solar exposures, that the inadequacies reveal themselves. By then, the builder is long gone. The warranty has expired or doesn't cover settlement and movement, and you're left holding the consequences of decisions you didn't even know were being made on your behalf. There's also the issue that almost no one discusses during the planning phase: how an H-shaped footprint impacts your land use and site costs. Because the building sprawls in multiple directions, you need more cleared land, more grading, potentially more retaining walls if your site has any slope. You need longer utility runs to reach the far ends of each wing. If you're on a septic system, the drain field has to be positioned to avoid all that building footprint, which can mean pushing it farther from the house and adding pump costs. If you're in an area with heavy snow, you need to think about drift patterns in that courtyard space between the wings, because snow doesn't distribute evenly on complex shapes. It piles up in corners, overloads roof sections, creates ice dams where wings intersect. One family in Montana built a beautiful H-shaped barndo and spent their first winter shoveling the courtyard every other day because the wind would funnel snow into that protected space and stack it 4 feet high against the doors and windows. They loved the design in summer. They cursed it every December through March. Then there's resale, and this is where the long-term failure really stings. If you build an H-shape and it develops the kinds of problems we've been talking about, you face a brutal choice when it's time to sell. Do you disclose the cracks, the movement, the history of repairs, and watch buyers walk away or lowball you? Or do you patch and paint and hope the inspector doesn't catch it, risking legal trouble down the road? Even if your H-shape build is structurally sound because you did everything right, you're still selling a home with a complex footprint that limits your buyer pool. Families love the idea of separation until they realize separated wings mean longer walks in the middle of the night when a kid is sick, higher heating and cooling bills, more square footage to clean and maintain. Empty nesters who might have wanted that layout when they had a full house often downsize before the problems appear, leaving the next owner to inherit a beautiful design with latent engineering flaws they have no idea how to assess. Appraisers struggle with these homes too, because there aren't always good comps for H-shaped barndominiums in rural areas, which means your value gets estimated conservatively. And conservative estimates mean you're leaving money on the table after you've already spent extra to build something distinctive. So why are structural engineers finally speaking up now, in 2026, after years of these builds going up? Because the data is catching up. The first wave of H-shaped barndominiums from the boom years of 2019 and 2020 are now 5 and 6 years old. And that's exactly the window when these movement-related problems start showing up in force. Engineers are getting called in not for new builds, but for forensic investigations, for repair designs, for homeowners who are panicking because their dream home is cracking and they don't know why. And when engineers start comparing notes, patterns emerge. They're seeing the same mistakes repeated across different states, different builders, different kit companies. They're seeing families who were sold on the layout but never educated about the engineering. They're seeing builders who meant well but didn't have the technical depth to execute a complex shape correctly. And they're realizing that staying quiet, letting the industry keep selling H-shapes without addressing these vulnerabilities, is doing a disservice to families who trust that if a builder offers a plan, it must be sound. The engineers aren't saying don't build an H-shape. They're saying if you build an H-shape, do it right. And here's what right actually looks like. It looks like hiring a structural engineer before you finalize your floor plan, not after. It looks like budgeting an extra $15,000 to $30,000 for the foundation reinforcement, the engineered connections, the proper flashing and expansion details that a rectangle wouldn't need. Thanks for watching. If this was helpful, please like, subscribe, and leave a comment. I'd love to hear what you're building. See you in the next one.